Hello, my name is Eliza Bosmans, and this is Lab 1 charge tapes for Physics 2. To start, the purpose of this lab was to determine the charge, sign, and magnitude of a piece of tape and observe its interactions with different objects. The results ended up being for the U tape, it had an overall charge of negative 2.39 times 10 to the negative 9 coulombs, and the ratio of electron deficiency to atoms on the tape is 1.49 times 10 to the 10 electrons per atom. Some key ideas and equations that were used in especially the coding and calculation of this was Coulomb's law, which describes the force of a particle on another particle, where this is just K, a constant, which is 1 over 4 pi epsilon naught. These are the two charges. This is the distance between the two charges. And then the electric field describes the electric field of a charged particle, this being the charge, the distance, particle. And then the gravitational force is just the force of gravity acting on the particle. Mass is the mass of the particle, and gravity is gravitational constant. The experimental design of this was, the system was tape B and tape A, and the surroundings was everything else. And the assumptions were that air resistance is negligible, tape is at a point charge where all the charge is concentrated at the center, and each U-tape has the same amount of charge evenly distributed along the length of the tape. Some initial conditions were that 2 pieces of neutral tape equal in length and a third laid out flat. And then some experimental observations was that tape B was stuck onto the third piece of tape and ripped off quickly to generate a charge on it. This tape was held near various objects to determine its charge and then placed above tape A until a portion of it floated. Distance between the tape was measured to calculate its charge. And then the other observations that were done in the same method where the tape was ripped off was that the hand was attracted to the tape. U-tapes repelled each other because I think they were both the same charge. And then neutral book was attracted to the tape as well. And a negatively charged pen, which was like rubbed up against hair to kind of charge it like with friction, was attracted to the tape. And then some of the conclusions that we came to were that the tape is negatively charged. The mass was, I mean, you can look at all the data right here. This doesn't really mean anything when I read it. And then we assume that the acceleration of the tape is the same as the gravitation because it was still when the U-tapes were next to each other. We can calculate the charge on the tape using this charge of the electric field and the force of gravity. And then we have here the calculation found, and then the electrons lost by a piece of tape was right here. And here is the computational model that we did. These are all of the constants that we had. This is this value K right here, that 1 over 4 pi epsilon naught, charge of the electron, tape mass, tape length, tape width, gravity, gravitational constant, and distance, the atom length, which is another constant, and then scale factor for the image. And then this is the same calculation that was back here, where we set these equal to each other to calculate the charge on the U-tape using gravity because it is held in equilibrium whenever it's still like that. And then these are the rest of the calculations that we had here to calculate the atom length, or sorry, the atom count and the other distribution. And then this is just coding these arrows and spheres. And we use the location here. We use this standard distance that we had measured before between the two tapes. And then we used the other constants up here as well to map that. And then some errors that we had were in the model discrepancies, which no true point charge because it's a piece of tape and we just ripped it off a desk. So it's not going to be like exactly equal or exactly a point charge. And then other sources of error were unequal charges on U-tape, and the Q is not the same. And then whenever you are holding the tape, some of the electrons dissipated most likely if you didn't hold the handle exactly right or you let it touch something. So that also could have caused charges, and that did happen where we had to recharge the tape because of mishandling. And then what would happen if electrons and protons were switched? The observations would have not changed. Instead of losing electrons, we would be losing protons, but the same result would happen. And then it's important to handle the charge tapes carefully because charge can transfer, like I was saying before, and dissipate through physical contact. Kind of like when you're holding onto an electrical wire and electrons flow through you because your body is conductor, not an insulator. So that is why you had to be careful about handling the charge tapes. And that is the end of the slideshow. Thank you for listening.